Hi everyone, good morning. This is sixth video in JCL. In this video we are going to see GDG, Generation Data Group. It's a simple and straightforward as well as the very useful concept in production environment and our day-to-day life. Without GDGs, many activities which we do in real time would have been much more complicated. Before getting into that, I would like to ask a question in GDG. Those who are experienced, they can see whether they are able to answer and they are confident of their answer. If that is the case, they can exit this video. Okay, if they can take it granted that they know everything on GDG. Okay, this is a GDG. Before running the job, GDG base is in place. So what I'm doing here is base followed base of +2 is the one first I'm creating. That is, without creating +1, I first create +2, whether it is allowed. Then I'm creating +1, then I'm creating +3, then I'm giving a GDG base and try to give a display of all GDG base content. So whether I can give GDG base like this instead of generation, that is the second question. So the first question is this. If at all this step successfully executed, which generation will be created? G0001V00 or G0002V00. Which one will be created here? Which one will be created here? That's the first question. Second question, as I already said, when I give a GDG base, whether it is allowed, if allowed, what will come in the output? Whether first G001 content followed by 2 content followed by 3 content, or 3 followed by 2 followed by 1. So how the outputs will come when I execute this job? These are the two questions. If you answer and you are confident of your answer, skip this video. Okay. Now come back to theory. What is GDG? GDG is used to store and access the dataset that are related functionally or chronologically in a easy way. First step, we need to create the base, then we can create the generation with a convention of G00, G 4-digit number, followed by V, followed by 2-digit number. This with the suffix of a base. So all these will become a generations of the data set. First, we will see in an example why our GDGs are very useful in real time. See, this is one data set. This data set I am taking a copy. Okay. So, assuming GDGs are not there, what would have happened is, today I am taking a backup. I will do it in 27 and I take a backup. And tomorrow, again I need to take a backup tomorrow, end of the day. I need to change the dataset name. This is a JCL. This JCL I need to make a change and submit. Assuming this backup dataset used in the second job, there also I need to make a change. In production environment, it is nonsense. Every time I cannot change and submit. So this is not a way we can create a backup. So we need to have some other way. For that convenience only, GDG came to picture. So first we'll submit this job to take a backup. And then what we do is we create a GDG and tell you that how you can use the GDG here so that you no need to change the job every time. Okay. This backup, let's take, I think this may be already there. So I'll go with 28. Okay, this is simple backup. Now I'll say, GDG creation. GDGs are created using IDCAMs. Okay, GDG name, base name can be, this is name, under name, what we are giving is GDG base name. This base name is of 35 characters only. You know that all physical sequential data sets, we can have it with 44 characters, but the generation, these 9 characters will be, the suffix use 9 characters, so base can contain only maximum of 35 characters. And limit will say that how many generations for the base can exist at a time. So what I am mentioning here is 5 only, so at any point of time, 5 generation only you can see it. What is the maximum number I can quote here? 255. 255 is the system limit, 5 is the limit I given for this generation, GDG. No empty. What the no empty says is, once all the 5 generations are utilized, you are trying to create the 6th generation, what the system has to do. When I do no empty, what it will do is, it will just uncatalog the first generation alone, and your 6th generation will become a 5th, and everything will move one step before. Okay. If at all I coded the other option empty, when 6th generation I try to create, all the prior 5 generation will get uncatalogued and your 6th generation will become a latest generation as well as first generation of the data set. Okay. Purge. What the purge will do is, for the uncatalogued one, like as I said, 6th generation comes, the first generation going off, right? What has to do with that with respect to deletion? Physical delete will happen if we code purge. If we give no purge, the physical delete don't happen. So these are the 4 parameters. On top of it, there is an additional parameter of expiry date we can give by, for how many days like that. That I'm not, that's not so critical. So I'm leaving. In fact, these two also, you leave to default. Default is no empty purge. This two is good enough to create a GDG base. So as I said here, we can create using ID camps. We can also create using IKJFT01 or TSO. Probably I can tell you that how you can create using TSO also. Before that, let me submit it. So BKUP, instead of that I will create BK, I don't know, already some versions and maybe I would have tried out. So I create BK now. So this base is created now. If I go and see, this is a base. Now the same thing I can do it with using IKJFT01 or terminal commands like TSO define GDG name, you can give Z82660 dot GDG GDG1 limit is 2. That's it. If I give like this, GDG1 is a GDG generation base name. I'm going to create like that. Somewhere I missed a code. Where I missed limit is 2. GDG1. Okay, I put a code there additionally. Okay. Created. GDG1 is on something created, right? This is it. So like this, IKJFT01 or TSO commands or option 6 or ID camps, with anything you can create, but usually people use ID camps for creating the VSAM related defense stuff. VSAM and GDG means ID camps. Okay. So this is about GDG. So now GDG is created, BKGDG. What I will do is, once I create the GDG, instead of this way, I can give BK relative way. If I code like that, what will happen is the first generation of the base will be generated. That is the first version. Let's go and see. This is the first version. This is created. Okay, backup is done. So tomorrow FA again I need to run. No need of any changing. Simply submit it again. That's it. So what happens now? G00, because of this relative way of specifying the generations, new data set will be created. Okay. So let's try it out. We have created this base with 5, right? Let me create 5 generations. 1, 2, 3, 4, 5. So I created 5 generations now. Okay, limit is done. You try to create a 6th generation, what will happen? We will see. As I already said, your first will be uncatalogued and 6th will become 5th. And everything will be shifted one level down. Okay, that is what happened. 2, 3, 4, 5, 6. Now, how to access? Now we have created +1 in a JCL that says that create the next generation. Now we'll see if I need to refer it in a program, in a job, how to do that. See, this generation is called, 0. Like this, I can refer this. And this one I can refer like -1. This one I can refer whenever I need to read it, I can do -2. So like this, I can go ahead and use it. 0, the prior version -1, prior to prior -2, like this. Similarly, if I want to create the next one, I'll create in my job +1. That is new data set. The next one plus 2, next one plus 3, like this I can create. Okay. Anytime I want to refer the plus 1 which is created in the first step, in the second step, I have to code again plus 1. Okay. We'll see that in example how to refer it. Okay, GDG2. GDG2, its definition, maybe GDG3. What this is doing? This is doing creating the backup of BK, right? We'll go with BK. Here what I am doing here. Okay, here what I am doing is I am writing one BK plus 1. So when it is happened, already 6 generations are there. So 8th generation will be created when I run the first step. Okay, 6 versions are there, and 8th version, 6 or 7th will be created here when I am running this, and the content will be this. And then when I am running this step, what will happen? This step I am using as a input as a 0. So what is the 0th version? 0 always say current version. Current version is what? Current version, currently though already in the first step, 7th generation is created. When I refer current generation, remember this is the most important concept in GDG. This generations referred only before execution of the job. So 0 means only this will be referred, not the one we created with, okay, that this one always whenever we need to refer within the job, we need to refer coding plus 1 only. Okay, 0 means just before start submitting the job, what is the current generation, that one only will be referred. So in this case what will happen is this will be referred. To know that this is what referred, I'll write I am current. Okay, I write here I am prior. Okay, next is this is minus 1. So I'll see I am prior display here. What I am doing here I am giving a minus 2, again the one before, like this it will come. Or the last exercise we will change, we will give plus 1. This say that plus 1 is what you created here, that will be referred here. Okay, let's run this. So let's go and see, only just 7 would have been created now. Okay, 7 will have a display of things like this, and your 6th will have I am current. Now I am going to give in the display how it comes. The references we can confirm only from there. Okay, step 3. Step 3 I am prior. Step 3 is referring minus 1. Yes. Step 2 is referring current version. So step 2 is referring I am current. Okay, and this will be like a learning, because this is a one which created in this job. Okay, so I think you have a fair understanding of how to refer the generations by a relative way in a job. Okay, and another important concepts and in real time and theory perspective also is for whatever reason I am creating restart step 2. When I do a step 1, after that there is one step 2 is there. Step 2 is abandoned. Okay, this assuming this is step 3. Okay, step 2 is abandoned. Then I am starting from this, which is step 3 means the reference what I am giving 0 would have been changed to the GDG created here, because the generations are getting updated end or abandon of the job. So this plus 1, what happens is this would have become a 0. So if at all your intention was to use only the earlier one, before restarting you need to change everywhere, adjust the generation like minus 1, minus 2, 0. Like this you need to do manual adjustment whenever you do a restart of a job. Okay, keep this in mind. Okay, now what I will do is I will try to give a plus sign here, whether it is allowed. Yes, it is very much allowed. Okay. Now what is the setup? 7 till 7 things are there. If I do 10, what will happen is this, whatever the current generation, okay, in that 10 will be added and the new generation will be created. Means 17 is the generation. But remember, if I do refer the 0, the 17th only will be read. 7 will be -1, 6 will be -2. That is the relative way of generation. The number what you quote here, with that the absolute generation will be created. I can give here even 200, okay. So doesn't matter, okay, that is what I want to say. What number you quote doesn't matter, that number will be added and actual name will be created with that suffix. Now 200 will be added. So 217 is the new data set. Okay, that is how it is created. Okay, keep that in mind. And so for that reason, what I am saying is, if first step is 200, second step is create 100, third step is create +1, everything is valid. Okay, but only thing is, the relative way they all stand. The number which is the greatest number, that will become a latest generation. In this case, this is the latest. This is -1, this is -2. So how the generations are named, what is the purpose of the relative generation +1 and +2, and how we can refer back the older generation, everything we are aware of it now. Now one more thing we are going to discuss now is generation GDG base. GDG base, if you give it as an input, you will be taking all the generations concatenated and you create the output. The example what we are going to see here is, I will give a BK data set. Okay, this is a BK data set. This is concatenating. I have what? How many? 5, right? 5. So if I run it, the content will be same. So assuming that you have 200 backups, for whatever reason you want to concatenate everything and see the value on daily basis or monthly basis or yearly basis, what you can do is simply give a base. You don't need to manually concatenate it like this. Both are same. That is what I am trying to say here. See how many lines? 13 lines created here, which is learning GDG concept and followed by this here, learning GDG concept followed by this. So the contents are same. So when you give a GDG base, the generations are concatenated in the order of current to oldest. Okay. So I think we are good with GDG, and as I said, two important concepts. Generations are updated only end of the job or end of the job. Whenever you restart a job from a step where the prior step creator GDG or generations are referred, make sure you are appropriately adjusting before the restarting. Third, the GDG base, when you give, the generations are concatenated from current to oldest. Then ID camps is used for creating a GDG. And then a limit, you should know the parameters, and also at any point of time, the maximum system allowed limit is 255. I think we are good with GDG. Thank you for watching.